Hello everyone. In this video, we will cover linear inequalities in two variables. We will begin by defining what is an inequality in two variables and how do we solve it. A linear inequality has one of the following forms, where a and b cannot both be 0. So how do we solve it? Just like inequalities in one variable don't have a single value as a solution, but a range of values, so do inequalities in two variables. These solutions are all the order pairs x and y's that when we replace them back, it will result in a true statement. So let's look at example 1. It's asking us to determine if the given order pairs are a solution to this inequality. So let's give it a try. The inequality is y is greater than x plus 4. This is your x and this is the y. So let's replace them. This will be 0 is greater than 0 plus 4. If we simplify the left, that is just 0. When we simplify the right, 0 plus 4 will be 4. And the question is 0 greater than 4? Well, since 0 is not greater than 4, that is not a true statement. That means that 0 is not a solution to this inequality. Let's try now 1, 6. We bring the inequality once more. We check the values given. In this case, x is 1 and y is 6. We replace them in the inequality. That is 6 greater than 1 plus 4. We simplify the left. That's just a 6. We simplify the right. 1 plus 4 is 5. And we ask, is 6 greater than 5? Well, this time, this is a true statement. 6 is greater than 5. That means that 1, 6 is part of the solution to this inequality. So then let's see if we can figure out what relationship is there between the solutions of an inequality and its graph. In example 1, we found that this inequality had 1, 6 as a solution and that 0, 0 was not a solution. So I'm going to bring the graphing calculator to help me find a relationship between the solutions and the graph. I'm going to enter this inequality as the equation y equals x plus 4 in the calculator and go look at the graph. When I am at the graph, I see that 0, 0, it's down here, is below the line. And below the line was not part of the solution. But 1, 6 is above the line. So that means that above the line is where I'm going to find my solutions to these inequalities. But why is that? If I look at the inequality, this one is stating that y is greater than the line. So when I look at the graph itself, since this blue one is the line, and it's saying that y has to be greater than the line, that's why I'm going to be above the line towards the positive y's. If the inequality had been less than, that would mean that y had to be less than the line. So then the solutions will be below that blue line. So let's try another example. From what I saw in the graphing calculator, I can say that graphing linear inequalities into variables when solving for y will take the following. If it's greater than, I'm going to shade upwards towards the positive y, but since it's greater than only, I'm not going to include the line. When we were working with solving inequalities in one variable, we would use either open or closed circles, parentheses, or brackets. But since we are creating a line here, we have to use a different method. So we're going to use a broken or dashed line to mean that we are not including the line. If it's greater than or equal to, we're still going to shade upwards towards the positive y. But since we are including the line because of that equals, we are going to use a solid line. It will be similar for the less than or equal to. We will be shading downwards towards the negative y's, But if it's less than only, we don't include the line, we use a broken or dashed line. And if it's equal to, we will include the line and use a solid line. For example 2, we're going to use the same inequality as example 1. We have y is greater than x plus 4. Notice how this is already solved for y. So what we're going to do is we're going to change that inequality into an equation so that we can use the following. So this would be y is equal to x plus 4. Notice how this is in the form of y equals mx plus b. When we were back in graphing linear equations in two variables, we stated when you have an equation of the form y equals mx plus b, we plot b first. In this case, b is 4. So I'm going to do that. I'm going to go to my graph and I'm going to plot that b, that 4. Remember, b represents the y-intercept, so that's why I'm placing it on the y-axis. From there, we use the slope to find our next point. So the slope represents rise over run. In this case, the slope is this value in front of the x, which is 1, even though we don't see it. Since I need a rise over run, and this one is a whole number, I'm going to place it over 1. So then I have a rise of 1 and a run of 1. So I'm going to go 1 up and 1 to the right because they're both positives. Now you don't necessarily have to just plot another point. You can plot as many points as long as you continue to go 1, 1, 1 up, 1 to the side, 1 up, and 1 to the side. The more points that you plot will help you when you bring your ruler to create a more exact line when you connect them. In reality, you only need 2 points to graph a line. Looking back at the inequality, since it's only greater than, is not equal to, that means that I'm not including the line. So then when I connect these points, I'm going to do so by using a dash line. Because it's greater than, we're going to shade above the line towards the positive y values. So where exactly is the solution to this inequality? Well, the solution to this inequality are all the x and y points above the line, but not including the line. Let's move on to the next section and see if we can use everything we've learned. Let's now graph linear inequalities in two variables. The steps that we're going to take to graph linear inequalities in two variables using y equals mx plus b are the following. First, we're going to solve for y so that we can use the inequality to help us shade. Next, we're going to change the inequality to an equation and graph it using y equals mx plus b. And then we draw the line and shade according to the inequality. We have to be careful here in step 1 because we have to remember that if we end up dividing by a negative number, we must flip the inequality. So let's try example 3. It's asking us to graph the linear inequality 3x minus 4y is greater than or equal to 8. So let's bring the inequality and we're going to do step 1. We're going to solve for y. The first thing we're going to do is we're going to move this 3x to the other side. On the left side, 3x minus 3x gets eliminated, leaving me with minus 4y is greater than or equal to. Now, I cannot combine the 8 with the 3x because they're not like terms. But since I want to use y equals mx plus b, I'm going to write the x's first and then that constant. We are not complete. We still need to divide by that negative 4. So let's do that. We're going to divide by negative 4 each of these terms so that we can solve for y. From left to right, negative 4 divided by negative 4 will be 1, 1y, or just y. On the right side, I cannot divide 3 by 4 evenly, but because of the negative negative, I know that this will turn into positive 3 over 4. Don't lose x. and then 8 divided by -4 will be -2. Now being very careful here, because we divided by a negative value, we are going to have to flip that inequality. From there, we're going to go to step 2, and we're going to change this inequality into this inequality right here into an equation. So this becomes y is equal to 3 over 4x minus 2. And we have that b, our y-intercept is -2. So we plot that one first, -2. And our slope is 3 over 4. That means that we're going to go 3 up and 4 to the side. So let's do that. We do 3 up and then 4 to the side, and it lands the next point right here. Once you have plotted your point, you're going to go back to the inequality to see if we can or cannot include the line and if we should shade above or below the line. Now, at this moment in time, we have two different inequalities. The original inequality, the one that is greater than or equal to, and then we have, when we solve for y, the less than or equal to. We are going to use this inequality right here, the one when we solve for y, because it is this inequality that we change to an equation to help us graph. So this is the inequality that we're going to look at. Because it is equal to, I'm going to use a solid line because y can equal the line. Once we have our line, we return back to that inequality to see if we should shade above or below the line. Because it's less than, we're going to shade towards the negative y's. So then the solution is going to be all the points that are below the line, including those on the line. Let's try another method. Let's say that solving for y is not something that you particularly like, but you remember about x and y intercept when you were graphing equations. So then the steps that we're going to take when graphing linear inequalities in two variables using intercepts will be the following. First, we're going to change the inequality to an equation. Then we're going to find the x and y intercepts. We're going to draw the line according to the inequality, but this time we're going to have to test a point above or below the line. If the test point is a solution, then we shade in that direction. But if the test point is not a solution, then we're going to have to test in the opposite direction. So let's try this inequality. It reads 2x plus 3y is greater than 6. So let's begin by changing this inequality to an equation. This will be 2x plus 3y is equal to 6. We're going to find the x-intercepts and the y-intercepts. If you remember, to find the x-intercept, we're going to let y equal to 0. So then we replace that. I will have 2x plus 3 times 0 is equal to 6. This is going to go to 0, leaving me with 2x is equal to 6. We divide both sides by 2 to solve for x, and we get that 2 divided by 2 is 1x, or just x, and 6 divided by 2 will be 3. So then the x-intercept is going to be located at 3, 0. Let's go plot that. So 3, 0 will be on the x-axis at 3. Let's try the y-intercept now. We're going to let x equal to 0 this time. So then in our equation, this will become 2 times 0 plus 3y is equal to 6. 2 times 0 will go to 0, leaving us with 3y is equal to 6. We divide both sides by 3 so that we can solve for y. And 3 divided by 3 is 1y, or just y. And on the right side, 6 divided by 3 will be 2. So then our y-intercept is going to be 0 on the x and 2 on the y. So we will go plot our y-intercept on the y-axis at 0, 2. And here it is. We're going to go to the inequality next to check if this is going to be a solid or dashed line. Because it's only greater than and not greater than or equal to, our line will be dashed. Because we did not solve for y, we cannot use this inequality to make the decision if we should shade above or below the line. If you remember in example 3, sometimes those inequalities end up flipping if we had solved for y. So we have to make sure that if we don't solve for y, that we test a value. So I can test a value either above or below the line. It doesn't make a difference. If it works, we shade in that direction, and if it doesn't, we shade in the opposite direction. I'm going to test 0, 0. We test the value in the original inequality to see if we get a true statement. And this will become 2 times 0 plus 3 times 0 is greater than 6. Well, 2 times 0 will be 0, and 3 times 0 will be 0, which means that on the left side, I have a 0. On the right side, I have a 6, and I know that 0 is not greater than 6. So then 0, 0 is not part of a solution for this inequality. That means for us that when we shade it, we are not going to shade towards 0, 0. We're going to shade in the opposite direction. So then the solution to this inequality will be above the line towards those positive y's. Please remember that if you don't solve for y, you cannot use that inequality to make the decision in which direction to shade. You are going to have to test a value. Let's move on to the next section. In this last section, let's graph vertical and horizontal linear inequalities. We have graphed before inequalities in one variable, but when we did that, we were being asked to graph it in a single number line. Right here, they're asking us to graph this inequality in an x and y coordinate plane. So how are we going to do that? If you are given y is less than or equal to 3, we're going to begin by changing this inequality into an equation. So this is y is equal to 3. If you remember when we were graphing linear equations, this is a line passing at y equals to 3, and it becomes a horizontal line because we are only given a y value. Now, since the inequality is less than or equal to, this line is going to be a solid line. From there, we have to make the decision if we should graph above the line or below the line. Well, because it is, again, less than, we're going to shade below the line towards the negative y values. So then the solution to this inequality are all the points that are below the line, including the points on the line. For the next one, I'm only being given an x. So then the equation becomes x is equal to negative 1. Once more, we locate where x is equal to negative 1, and that's right here. And since we are only given an x, this becomes a vertical line. We check the inequality to see if it's dashed or solid, and since it has that equal to, we're going to make a vertical line that is solid. Now notice that this time we don't have an above or below the line, we have a left and a right. But the inequality states that we want to be greater than or equal to negative 1. Since I have a left and a right, I know that the numbers on the right will be greater, so then I shade to the right side of this line. That means that the solution to this inequality will be all the points to the right side of this vertical line, including the line. I really hope that you find this helpful. Thank you so much for watching, and I'll see you in the next one.